Start.
No, we're not drawing. So what's on the screen right now, guys, was the one that we constructed for a hexagon. And what we did was take our circle and we divided by the number of sides. So this is important. Circle 360 degrees divided by the 6 sides for the hexagon. And we started by constructing with just 3 lines, the 60 degrees. And I want to point something out to you guys that were in here earlier. Since I made a hexagon, what's true about these triangles, guys? Well, all the angles are, but what's true about this triangle? What kind of triangle is that? It's equilateral, which by definition means these are all 60 degrees. The other thing that should be true about an equilateral triangle is that all sides should be exactly the same. So this one's 6 centimeters. I didn't measure my outside marks because of the way we constructed it, but if I do, I can see that they look like they're 6 centimeters. That's another way to check it. Okay, that was pretty easy to do on a piece of paper. However, you guys are going to be constructing on a piece of cardboard like this. So here's a way to start that process. I'm going to use a pencil to do this part because it's not part of my design. I'm going to find the diagonals of this. It's not really a square because I didn't get cut super carefully. But there's one diagonal, and then here's another diagonal. What is this going to help me determine on my square? My not quite square. What did I just find? All right. I found the center. That's important to me because I don't know about you guys, but I really don't want to run out of room. So if I started my polygon like over in this corner and I couldn't get as big a polygon as I wanted to because I ran out of room, that would be a little upsetting to my group. So we're gonna construct an octagon together. Okay, so I already know that I'm gonna take the number of degrees in a circle and divide by the number of sides in an octagon, which is 8. And that tells me what the interior angles should all be. So what is 360 divided by 8?
Near 50.
It's near 50, that's true.
45.
It is 45 degrees, nice mental math. So I know that all of my angles in the middle need to be 45 degrees. The reason I drew these diagonals in pencil is because those don't necessarily have to be part of my design. They could be for this particular polygon, but they wouldn't work for a hexagon or a pentagon or any of those. So I'm just going to kind of get rid of those. So if I notice my cardboard, it's only really about 13 centimeters across and 13 centimeters up and down. So length of 13 centimeters, width of 13 centimeters. I can't have anything past that in my polygon. But I'm going to start the same way, but I'm going to use my midpoint and I'm just going to construct a line. And at this point, I'm not really worried about how long that line is. There's my first line. And I know from this that my interior angles have to be 45 degrees. So this is when I use my protractor carefully. And I'm going to find 45 degrees. And I'm going to place a dot there. And then I'm going to connect these 2 dots to form 2 of my interior angles. Then I'm going to use this new line that I drew as my new base. And I'm going to find another 45 degree angle. And I'm going to do the same thing by connecting those 2 dots. Then I'm going to use this line I just drew as my base, slide my protractor down, find 45 again, connect to those 2 dots. And notice I say connect those 2 dots, but really I'm connecting past those 2 dots. And before I go any further, I'm just kind of like eyeballing this to make sure my interior angles look like they're about the same. I don't see anything that's like garishly wrong. And I'm working in Sharpie. Hopefully when you guys are doing your design, you'll work in pencil, because you have the potential to make some mistakes.
Can I show them what
Sure.
mistake I made? Speaking of mistakes, when I was working with Austin earlier,
Come over here because we're recording
yeah,
right
I'm
here.
going to. I had to get the paper. This is a This is a decagon. And I have a little bit more work on here because I was showing how to find area too. If you look right here, I made a mistake with my distance from the middle point to right here. Instead of I was trying to measure off 6 centimeters, and I measured off 5 or 5.5 for some reason. So, and I recognized that it had looked a little bit irregular like that. Do you guys notice it kind of looks a little bit irregular?
Yeah. Looks like a little squashed.
Yeah. And then I noticed, okay, I'm going to remeasure mine. And guess what? My measurement was wrong. Fixed it, redrew the line, so it shows my error on there.
Right, and you guys, when we talked about before on this one, where we extended our lines past, and that helped us identify this mistake on this one. That would have worked here too if you extend your lines, because you're cutting this out. So if you extend your lines past, I'll do the old line, the wrong one. These angles here, these exterior angles, would help you realize that, oops, that's not right. So let's go back to this. I do think that you probably want to start with the biggest circle you can, because you can always make it smaller, but you can't make it bigger once you cut it. So, Josh, are you with me?
Yes, I am.
Okay. I'm going to make sure you guys understand this. This part is pretty critical, and this is probably how Mr. Notley made the same mistake that we made on our hexagon. Instead of trying to measure each leg right here, 6 centimeters, 6 centimeters, 6 centimeters, I know I have an even numbered polygon, an even number sided polygon. You guys have a question over there? Jacob? Are we good? Awesome. So here's what I'm going to do to make sure that I did not make that mistake again. I'm going to focus on this 6. I want 6 centimeters, and I know that's hard to see up there, so let me change to this ruler. I'm going to focus on the 6. Can you guys see that? And then I'm going to make sure that this line goes, and I switched colors so you can see it. This line goes to the 0, and I'm going to put a little kind of hash mark there. And then I know I need to go to the 12 on this side. I'm going to put a hash mark there. And then I'm going to do the same thing to all my other lines. So I'm going to make sure that 6 is right in the middle. I'm not looking at the edge of my line. I'm looking at that center point and the 6. In other words, I don't want to line it up like this, because then my 6 centimeters is going to be wrong. And I'm going to put a hash mark at the 0 and a hash mark at the 12. So I know that each of those is 6 centimeters. And I'll do that in orange so we know we did it. Same thing to this one, concentrating on that 6. Hash mark, and my last line, concentrating on the 6 and the center point, hash mark, and connect. Okay, then I only have one final step. Let's see if you can figure that out. I haven't connected anything yet, but you can still count how many interior angles I have. How many interior angles do you see? So I'll start here. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be what? It's going to be an octagon, because however many interior angles I drew is the same for the octagon. I can go ahead and label these, because I know they're all 45-degree angles, and I think that's probably going to be important in your design hint. Label your angles. The other thing I know for sure is that these radius, my radii, are all 6 centimeters. I measured that. Then I'm going to do my last step, and I'm just going to connect. Now I'm really going to draw the octagon here. I'm going to connect my hash marks carefully. I'm looking for where they intersect the lines. Oh, that one didn't get very clear. Let's see if I can clear that up a little bit. And I'm just working my way around. Whoa, finger in the way. Don't do that. And then after this is done, I want to show you guys a secret to cutting these out without destroying your wheel. Okay, so I technically should have an octagon that's regular. Same sides, same angles. I did not extend my lines, but you guys certainly could. So this one could go past, because you're cutting it out anyway. That'll help you kind of use your eyeball to see if there's anything that looks really wrong with it. How can you tell that you did something wrong?
Well, because they're not equilaterals. Triangles are not equilateral.
Are you? What shape are you trying? What polygon are you doing?
Octagon.
Okay, let me see. Let's look at Sachi's real quick. So, this is your cardboard, and you have. So you're just missing one line. You have 1, 2, 3, 4. Are you looking? These aren't equilateral either. Oh, I know what you did. Sachi, yours is constructed just a little differently because you used your diagonals as 2 of your lines. So these 2 were 90 degrees. So you're 45. Like this is still a 45 degree.
Oh,
Can you
okay.
see that?
Yeah, I see.
And you have another, because this is vertical from that. So you know if you did another line this way.
Yeah.
You care if I write on this? There's your other 45 degrees.
Okay.
Now you just need to measure your radii from the center, and that'll give you your pentagon. As long as your radii are all the same length, you're in good shape. Okay? So here's the trade secret, guys, for those of you that are in here. You're going to cut these out with scissors. Here's what's going to mess this up. If I take this, oh, by the way, sorry, I'm going to back up one quick second, and I'm going to say, I know this is 6 centimeters, and my outside edge is about 4.5 centimeters. And that should be true for all of them. Then we're gonna take our scissors. Here's what's gonna happen. If I cut on this line, and then I try to turn this in my scissors and cut this way, and then turn it and cut, what's gonna happen to my...
It's going to be rounded.
It's gonna be rounded. So what I would suggest is, don't turn it. I'm gonna cut right on this line, all the way off. Then I'm gonna cut on this line, all the way off. I'm just going to keep straight cuts. I don't want to turn my octagon at all because I want super straight angles so I don't get penalized in the challenge. Hint, hint. Okay, and then in that way, now I have an octagon with a midpoint that might be useful because what's likely to go here in your design? The axle will probably go there. And you can also make some predictions about how your lunar rover will move based on this. Is there anyone in here that wants to do a pentagon or a heptagon? Is anyone thinking of a pentagon? Pentagon or heptagon?
Heptagon.
Oh, you're killing me, Smalls.
Heptagon, yeah.
I'll just quick show you what you have to do differently. So let's start with a pentagon, okay, Arian, because heptagons are their own thing. So I know 360 degrees divided by 5 for a pentagon. 72. So the problem with an odd numbered, I'm just going to start with a line. Problem with an odd numbered pentagon, an odd number of sides, is that you can't draw straight lines and then keep bisecting them like that. Okay, so one way to solve that is instead do a 360 degrees divided by 10. Do a decagon, which would be 10 sides. That's one way to solve it. So I would draw 5 lines and I'd have my 10 edges. And then I'd have to figure out in that shape where the pentagon is. The other way to do it, I know that I have to have 72 degree angles. So I'm going to start with a shorter line, and I'm just going to keep doing, now this way I have more of a ray than a line segment. I didn't extend it, right? Here's my middle, so I'm going to do 72 degrees. Try to be as careful as I can. There's one line. Going to use that new line to do the next interior angle of 72 degrees. There's another line. So in other words, I'm not going through, I'm not doing the diameter at all, I'm just doing the radius. In all of the other models with an even number, we were able to do the whole diameter in one fell swoop. In this one, you can't. You have to use just radii. Here's another 72. use that line to do my last one. And then after this, the process is basically the same. So now I have my 5 segments. Not super happy with them because I did it pretty quickly. I think most of these are 72 degrees, but I was moving pretty quickly, so I'm not super confident in this one. And then the rest of it's basically the same thing. You're still going to measure, I don't know, if you want 6 centimeters, that seems to work pretty well for the size cardboard you have. Measure here. You just have to measure each one. You can't do 2 at once this way. Measure here. Here. There's your 0. And one more. And here. And then last thing you do is connect your dots. Oh, that wasn't very good. So, Arian, you have a sense of how you're going to do this for a heptagon? The danger in a heptagon is there's a lot of estimation because you have that, it's like 51.2 degrees or something like that. And there's my regular pentagon.
That works.
Say that again?
It works really well.
Yeah, and then obviously if this were cardboard, I'd cut all the way across, all the way across. Just keep my angles nice and straight so that I have an actual pentagon. Instead of trying to move the paper. Okay, how's the one going that you guys are constructing?
Is this angles? That looks good.
Tell me, Andrew, tell me what made you ask that question. Does it look right to you? Is there part of it that does not look right to you?
I'm confused on the process.
Try extending your lines, because it looks right to me, but it will help if you extend your lines. So there's my pentagon, and I might make some judgments about how my rover will move if I use this shape compared to this shape. There's 2 different. And then, you know what? Remember Mr. Notley's that he drew? It's approaching more of a circle shape, because the more sides his polygon has. You can think about that when you're deciding. And here's the hexagon. Andrew, did you extend those? Let's see.